Good morning. Now you take down one problem based on bar magnet. First take down this question. A bar magnet AB is cut. A bar magnet AB is cut into two equal parts. One part is now kept over the other. One part is now kept over the other, so that the pole C2 is above C1. If M is the magnetic moment of the original magnet, original magnet, what would be the magnetic moment of magnetic moment of the combination so formed? Magnetic moment of the combination so formed. Okay, so now I will give you the picture of bar magnet also, how it is cut and where AB is, and so this one, so it is cut into half like this. Okay, and now we have here points are marked. This side is A, this side is B, and we have C1 at this end, C1, and this end is C2. Okay, C2. Let us read it once again. A bar magnet AB is cut into two equal parts, here as shown in this figure. Now one part is now kept over the other, so that the pole C2 is above C1. Now it is cut and then it is kept in such a way that C1 and C2 are one over the other. If M is the magnetic moment of the original magnet, what would be the magnetic moment of the combination so formed? Now we have to find out what is the new magnetic field of the combination, not the individual piece. We know the magnetic moment what the individual piece will have when it is cut from the original magnet. Now here we will mark the poles first. We'll take the same magnet, and then the poles are not given, but still we can mark it. So let us say this is the given magnet AB, and then it is cut into two equal parts. So I'll draw a line. And then we have C1 and C2 also marked. C2, and let us say we have this side north pole, on the other side we have south pole, or it can be reverse also, no problem. This is a given magnet. Now what happens? It is cut into two equal parts. Now when it cuts into two equal parts, we will have two new pieces, and we will mark the poles. Here one piece, and then we will have another piece. The size it looks little small, but it should be of same width, only the length becomes half. Okay, so something like this. Now again we have same AB. Is here, B here, this is C1 end, this is C2 end, and because this is north pole, this will be south pole, and this is south pole, this is going to be a north pole. Now it is given that after cutting, the magnets are placed one over the other in such a way that C1 and C2 are one over the above. C1 is over above C2, or C2 is above C1, something like that. So now I am going to place something like this, the same magnet. So let me say this is A side, and this is my C1. So I'll be placing, we will just check how it is placed. One part is now kept over the other so that the pole C2 is above C1. So we will make C2 above C1. So I'll mark this. C2 is above C1, that is why this is C1. So if this is C1, the other end will be A, and this is C2, the other end will be B. Now C2 side we have north, B side we have south pole. Similarly A side we have north pole, and C1 side we have south pole. And we know the magnetic dipole, when the magnet is cut into two equal parts, the magnetic moment becomes m/2 of each piece. So the original magnetic moment is m, after cutting, the magnetic moment becomes m/2 of each piece, or the magnetic moment of each piece is m/2. And what is the direction of magnetic moment? The magnetic moment is directed from south to north pole. We can mark it, south to north pole. So here for this magnet it is m/2 in this direction, and for the other magnet it will be in the reverse direction. Now both the magnetic moments are in opposite direction. So if you add them, the net magnetic moment will be 0. So magnetic moments of two bar magnets in such combination is 0. We can write those points here. Magnetic dipole moment is m/2. Now we will write the direction. The magnetic moment is directed from south to north pole. So moments of two bar magnets in such combinations are equal and opposite, and hence therefore the net magnetic, therefore before writing therefore we will write, in this case the magnetic moments of two bar magnets are equal and opposite. In in this case the magnetic moments of two bar magnets are equal and opposite, and hence resultant magnetic moment is 0. In this case means it is the combination of two bar magnets placed according to the given condition. When we place the bar magnets according to the given condition, we get both the magnetic moments are in opposite direction. These are vectors, so when we add these two vectors, it becomes 0. So net magnetic moment is 0. Now we can write net magnetic moment zero. Hope you understood this problem.